So now we're going to try to find the area of a triangle that we graph on grid paper. So I got triangle ABC, you see the coordinates of its vertices, and we want to determine its area. So let's see the direction we want to go. If I take a look at this triangle, like, what do I notice about it? Well, okay, it's it's a triangle, it's got three sides, but I'm looking up at angle A, and I'm wondering, is angle A a 90-degree angle? Is that angle 90? Well, I know that angles or sides of triangles form 90-degree angles if their slopes are opposite reciprocals. So if I take a look at the slope of this side here, to go from A to C, I'm going up 2 and over 4. So the slope of side AC is up 2 over 4, which is 1/2. And if I look at how to go from A over to B, I'm going to the right 3 and I'm going down 6. So the slope of side BA is going to be down 6 over 3, which is -2. Those are opposite reciprocals. So indeed, the measure of angle A is 90. And why do I want to know that? Well, if the measure of angle A is 90 degrees, then what I can end up doing is I can end up finding the lengths of the sides of triangle ABC, or at least the two legs of it, and that's going to give me a really good length and width, and then I can multiply them and find the area. Oh no, that's making me happy now if I can do all that. That's a lot of work, isn't it? Well, let's see. Not too bad, right? So if I got to find the area of triangle ABC, I first want to find the length of side AC. So to find the length of AC, I'm going to do my big old distance formula, right? I'm going to subtract the x value, so I believe it was -3 minus 1 squared. Do my distance formula. I love my distance formula. So let's see, that's going to give me -3 minus 1 is -4 squared is 16. And then 4 minus 2 is 2. When I square that, I get 4. So the length of side AC is the square root of 20. And if I do the same thing with the length of side AB, get my distance formula going again. So now I'm going to do 4 minus 1 squared, and then 4 subtract -2, and square that. 4 subtract 1 is 3, squaring that is 9. 4, basically adding 2 is 6, squared is 36. 9 plus 36, square root of 45. Okay, so now in order to find the area, I want to do my area formula, 1/2 base times height. So 1/2 times the square root of 20 times the square root of 45. Oh, goodness. Well, you might remember that when you multiply radicals, you're just multiplying the numbers underneath them. So the square root of 20 times the square root of 45 is the square root of what 20 times 45 is. And I know 45 times 2 is 90, so 45 times 20 is 900. The square root of 900 is 30. So the area of the triangle then is half of 30, which is 15. And why do I have 2 little dots on the bottom right corner of my screen? I mean, I did my area. What else could I do? Oh, yeah, I could box it in. What do we mean by boxing it in? Well, what I could do is I could put a big box around this thing. So I'm going to put a box around it that encloses the entire figure. And now I got some triangles. Let's call this triangle 1, let's call this triangle 2, and let's call this triangle 3. It doesn't matter what triangles you call them. So what I'm thinking is if I can find the area of the big red box, and if I can subtract the 3 areas of triangles 1, 2, and 3, what I'm left with is the area of triangle ABC. Let's do it. So if I go along the bottom, it looks like this is 7 boxes long, and 1, 2, 3, 4, 5, 6 boxes high. So the area of my box, 7 times 6 is 42. If I want to find the area now of triangle number 1, triangle number 1 has sides that are 6 by 3. So 1/2 of 6 times 3, that's going to be 9. The area of triangle 1 is 9. If I find the area of triangle number 2, it goes over 4 boxes, 2 boxes there. So 1/2 of 4 times 2, which is 4. If I find the area of the third triangle, this side is 4, the bottom is 7. So 1/2 of 4 times 7, that's half of 28, which is 14. And the sum of those areas then, 14 plus 4 is 18, plus 9 is 27. And check this out. 42 minus 27 is 15. So the area of triangle ABC is 15, just like we had before. Now, don't get me wrong. You want to do some distance formulas? That's great. It works only because triangle ABC was a right angle, or it was a right triangle. Angle A was a right angle. If you don't have a right triangle, you got to box it in. Plain and simple. So, and we don't even need triangles either. Check this one out. I have a quadrilateral this time with my vertices at A, B, C, and D. Let's see if we can find the area of this one. I'm going to do the same thing. I'm going to put a big old box around it. A big old box. Okay, what's the area of my box? Let's see. So it looks like I go across the top. I got 9 boxes across the top. And it looks like I got 1, 2, 3, 4, 5, 6, 7, 8, 9 along the side. So 9 times 9, area of the whole entire box is 81. And I'm going to pull out the 4 triangles. Call that triangle 1, triangle 2, triangle 3, and triangle 4. I'll find each of those 4 areas next. So for triangle number 1, it looks like the dimensions are 1 by 7. So the area of triangle number 1 is going to be 1/2 of 7 times 1, which is 3.5. Oh no, we got a decimal. It's okay, you can get decimals. They are your friends. So if I keep going, this side is 2, 1, 2, 3, 4, 5. So the area of triangle 2 is 1/2 times 2 times 5. And that's just an area of 5. Area of triangle number 3, it looks like it has a side of 4 and a side of 6. So 1/2 times 4 times 6, that's a value of 12. Triangle number 4 is 3 by 8. 1/2 times 3 times 8, that is 12 also. So when we add up these areas, 12 plus 12 is 24, plus another 5 is 29. So the sum of the triangle areas is 32.5. So then to find the area of the quadrilateral, subtract the box, or subtract the 4 triangle areas from the box. And when we do that subtraction, we get 48.5. There's the area of that figure. So yeah, decimals are okay. But don't you love boxing it in to find the areas? I know I do. It's my favorite thing to do in geometry.